Hello everyone, this is day 13. I will continue with the series. Um, Yesterday I was doing array questions, but now I'm bored with these. I'll continue with this later on. Let's try some other random questions. Let's do the binary search. It is present on this. Binary search. Given an array of integer nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return the index, otherwise return -1. Okay. So binary search is basically the what we do is we find the middle element of the array, right? And then we compare this element with the target. If it is less than this value, if the middle element is less than the target, that means the result will be in the later half, otherwise the result will be in the first half. So at each iteration, then we consider this as our search space, then we again compare it with the middle element. If it is less, then again, so at each iteration we divide the search space by half. That is why the time complexity of binary search is order of log n. The brute force approach without doing binary search is straightforward. We will start comparing with each element, and once we find the target, that is the result. That takes order of n time complexity. For binary search, let's do it in Java. So for binary search, we take two variables, low and high, and mid, three variables. Low will be initially 0. Low and high will represent our search space, the starting and ending index of our search spaces. Low is 0, int high will be the last index of our search space. Let's take the size of this array as n. So n is nums dot length. And high will be n minus 1, which will be the last index of the search space. Now we will check while low is less than equals to high. What we will do is we will check if we will take a mid as well, int mid. We will take mid as low plus so what we need is the middle index. So let's say if low is if these are the elements 3 4 5 6 7 8 and 0 index. So basically in this condition, if this is the search space, then we should get 6 as the middle index. If low is 4 and high is 8, then the mid should be 6. To get that value, what we can do is high slow is 4, and one sec. So if in this case this is the mid element, so 5 6 7 8, this will be the search space. So basically we want the difference of these by 2. that will give us the half, the number of elements in the half of this, and then we can add low to it. So the mid will be low plus high minus low divided by 2. Right, this will give the half of the number of elements in half of the array, and then we'll add low to it to find the mid. Got it. And then we will check if current value is our result. So nums mid is the target. That means we have got the result. So we will just return the value, return mid, right? And otherwise, if mid if nums mid is less than target, that means if the value we have found is less than target, that means we need to search it in the later half. So we will increment low to mid plus 1, then low will become mid plus 1, else high will become mid minus 1, because we want to search in the first half. And at the end, if mid is not returned, that means there is no such element, so we will simply return minus 1. Let me try to run this. So this is the iterative way of doing the search. We can also try to do it recursively. That would be much easier to do. So let's write a function public int recursive int nums, and it also takes a low and int low, int high, int target. Okay, now if we have found it, if let's take a mid. So int mid equals to low plus high minus low by 2. Now if nums mid equals to target, then we have got the result. So return minus 1. And what if one more case should be that if low is greater than high, that means we haven't found it, so we can simply return minus 1. Okay, otherwise this will give index out of bound. So we should check this condition first, then we will find, if this is not the condition, then we can find mid and check, and here we can return nums mid, and then we will check the other cases. So if nums mid is less than target, that means so nums mid, if this value is less than target, that means it is in later half. So we will return recursive search nums, low will become low plus 1, low will become mid plus 1, high will remain same, and target will remain same. Else will return recursive search nums, and low will remain same, but high will become mid minus 1 and target. I think this is good. And here we can return recursive search nums 0, target dot length minus 1 and target, nums dot length minus 1 and target. What is it? And here comma is required. Return mid, not this thing. I'll submit it. Cool. Next, I'll do this lead code one. Search insert position. Okay. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must return an algo in login. So I think even in this scenario, it is the binary search only, but if the target is not there, then we'll have to find this value, like we need to find the value where it should be inserted. So in any case we will find mid, right? And once we have got mid, then we can check if mid is less than the value, then it should be inserted after it, otherwise it should be inserted before it. That will give us the result 2 3 4. Acha, if it is bigger than this, then it could be 4 also. Okay, so let's write the binary search again. Int low equals to 0, sorry for disturbance, there is plane going. High should be n minus 1, and int mid, let's take it let's just take mid. So while low is less than equals to high, we'll calculate mid as low plus high minus low by 2. Okay, and then we will check if it is found, then what is it? If it is here's order distinct and target, return the index if the target is found. सॉर्टेड है ना, हाँ सॉर्टेड है, ठीक है, एंड टारगेट इज़ फाउंड तो हम रिटर्न कर सकते हैं. ओके, सो इफ नम्स मिड इक्वल्स टू टारगेट, then we can just simply return target. Else what we should be doing is नहीं, ये तो रिटर्न हो गया. इफ nums mid is less than target, then we need to do low equals to mid plus 1, else high equals to mid minus 1, and at the end we will come to conclusion that it is not found, but we will have a mid which will have some value before or after it. So at the end we can check if nums mid is also nums will always exist. It will not be out of bound because we are calculating and not updating mid. Nums mid, if it is greater than target, then return mid minus 1 or return mid. This is the same case ki if somebody is on second position and if the third position guy crosses it, what is the position of that guy? So if we are putting something on in play before this, that will not get mid minus 1, it will get mid position, right? Let me think again. So nums mid is less than 0 अगर target है तो. So if nums mid, if target is 2 and nums mid is 1, let's suppose if nums mid is 1, greater than है तो हाँ greater than in that case. So if mid is greater than 2, तो 2 यहाँ पे आ जाएगा, तो उसका position यही वाला position होएगा which is 1. Else if it is less, so 6 है और अगर ये छोटा है तो हमारा रिटर्न होगा मिड प्लस 1. Might not be initialized. Okay, let's initialize it to 0. पहले में we are getting wrong answer. So if we are getting target is fine 5, output is not target बाबा, output is mid. लास्ट केस में भी मैंने यही गड़बड़ किया था. Submit. I'm interested in looking at the solution for this. They are doing what they are doing. They are saying that in any condition it will be start. So that means this condition will never occur. Is it? Fine. Let's do this one. First and last occurrence. Given an array of integer nums sorted in non-ascending order, non-decreasing order, find the starting and ending position of the given target value. If target is not found in the array, return -1 -1. Okay, so इसमें 3 4 is the target. It is starting from 3 ending at 4. इसमें it is 6 is not there and इसमें तो nums is empty. And it could be at one position also, no? So and we need to find a, if we can do a log order of n solution, then we can simply iterate over this array and find the indexes, but they are saying to find it in log n. So we will do binary search, but it has some trick to it. Let's say if we find the middle element, I'm thinking out loud, so let's say we want to find 8. Okay, target is 8. We check the middle element as we do in binary search and it is equal, then there is a possibility that all the elements on the left also and right also are this same value. Okay, but for that we will have to iterate all on the left, like in this case we just need to we will check that here there is nothing and here we have found one element. So we will easily find 2 as the I mean we can easily find the starting and ending. But what if in cases where all the elements are 8? In such case we will have to start iterating from this to start and then from this to end. So that is order of n, and I don't think they are looking for that solution. So one thing we can do is, first of all, in first iteration we can find where this element is present. Let's say in any occurrence we find 8. We find 8. Once we have found 8, we need to check that once we have found 8, we need to check. Let's say we found this 8, we need to check we need to look for an index from where 8 is starting, and we need to look for an index where 8 is ending, like that. Okay, so once we have found 8, we can split this array into 2. This is one array and this is second array. Okay, and then for each array, we in the left side of the array we need to find the starting of 8. So I'll take some other scenario in this case. So let's say 8 8 8 9 10. Okay, so once we have found 8, we will split this array into 2 arrays. I mean, not exactly split by taking 2 different arrays. Just assume that we are splitting it from here, and this 8 will be present in both of them. This 8 which we have found. Right, now in this 8 we need to find the position from where 8 is starting, and in this we need to find the position where 8 is ending. Right, one more 8 should be here. In this we need to find where 8 is ending, and this will be the result. This is starting, this is ending. And to do so we can use, I think, binary search. Let me try to write it. Int low equals to 0. First of all, I'll find the position where 8 is present. It could be anywhere. In the first iteration when we'll do binary search, it could be anywhere, any 8 which we have found. High equals to क्या, and nums could be length of nums could be 0 na. So initially we can return if int n equals to nums dot and length. If n equals to 0, then just return new int -1 okay, and then high will be n-1 and one int mid will be there. For int I equals to 0, sorry, what I'm doing, I was zoned out, sorry. So while low is less than equals to high, we'll find the mid equals to low plus high minus low by 2, and we will check if mid is found. So if nums mid equals to target target. That means we have found one solution, so we have found mid. Let's take a boolean variable, boolean found equals to false. In this case we'll do found equals to true and break. Otherwise we'll check if nums mid is less than target, then low equals to mid plus 1, else high equals to mid minus 1. And at the end we can check if found is false. That means there is no such digit, so we can return this directly. Okay, now we have found the one element which is equal to this which is 8, which is at mid. So now what we need to do is we can start searching from, again we will do low equals to 0 and we will make high equals to mid. Okay, and while low is less than equals to high, we will find the mid to low plus high. We need to keep track of mid, so let's take one more variable, mid2 equals to mid. Low plus high minus low by 2. Currently I don't know what I'm doing, I'm just thinking out. So we have got mid. Now we need to check if it is less value, if this value is less, that means what if this value is equal or greater तो हो ही नहीं सकता, greater हो सकता है, greater तो possible ही नहीं है ना, because we are ending at this value, so greater तो possible ही नहीं है. So we will check if this value is equal, then we will search on the left. So if it is less, if nums mid is less than target, then we need to go further on the right. So we will make, if it is less, then we will make low equals to mid plus 1, else we will make high equals to mid. We will not do high equals to mid minus 1 because I don't think that will work, because this can give us the value which is not which is again low. Will it? Let's try with this. So now in this case, once we will get mid, that will be our, let's take a int result, int array result equals to new int of size 2. Result 0 में we will put mid. Mid will be result or low will be result. Low could be result as well, but low could get out of bound. Now again we'll set, this time we'll set low as mid 2 and high as n minus 1 and int and mid2 as and nothing else. So in this case again we'll do the same, but in this case if it is greater then we will do high equals to mid minus 1, otherwise low equals to mid. And again we can put this in result 1 equals to mid and return result. I don't know if this will work. I have some doubts in this value which we are setting, these values we are setting, because I don't know if mid will have this value or low will have this value. I'll have to dry run this to see. TLE, okay. I'm getting 3 and 5. Mid is here. Mid is updated. Output. We take a different test case. Okay, and what if it's present till the end? Okay, and what if it's the whole array is this? And what if there is only one value? Cool. Okay, it worked. This is some messy code, but at least it worked. So why I added this output, this will keep track of the window, because in each iteration we are either updating mid or low or high, and at the end we are not sure which if this value will actually contain the value the target, or it will be less or higher. So at each iteration we can keep track of the value which is equal to target, keep track of that index, and so similarly for second case as well. This is done. I'll mark them as done. Search and rotated sorted array. I will do these questions tomorrow now. I'm good for today.